Today's lesson is on tests for similar triangles. Do not mistake these tests for the test for congruent triangles. They're very similar, no pun intended, but they are a little bit different. So when we're looking at tests for similar triangles, there are four, just like we were looking for congruent triangles. And the first one states that they are similar if all sides are not equal, but they have been enlarged or reduced by the same proportion, so they have the same scale factor. So each side has to have the same scale factor. This can be done visually. So from 2 to 4, we multiply by 2, 5 to 10, multiply by 2, and 4 to 8, multiply by 2. If not, you would use the formula to work out the scale factor if you can't just do it visually. And this rule is called SSS. So three sides of one triangle are proportionately to the three sides of the other triangle, or they just have the same scale factor. The second one is SAS. Again, this means that a side and an angle and a side, remember it has to be sandwiched, two sides and an angle, so the angle is in the middle, and again they're proportionately increased. So 5 to 50 we multiply by 10, 3 to 30 we multiply by 10. So they've been increased by the same proportion or reduced by the same proportion, and there's a middle angle that is exactly the same. The third test is equal angular. So two angles now are the same, irregardless of the sides. So two angles are the same, and this goes back to when you learned construction of triangles. If we construct triangles with the two same angles, however our lengths are different, they will still be proportionately the same. So if you have two angles that are the same, it means that they're equiangular, or two angles of one triangle are equal to two angles of the other, so 2A's. There's the last one, which is the same, similar to congruency as well, which is the RHS, which is just a special kind of SAS. And this is saying that there are two right-angle triangles. The hypotenuse of the second side are proportionately increased. So if we're going from 15 to 5, we would divide by 3. And another side, whichever one it is proportionately, again, by the same scale factor. And we're dividing by 3. 6 divided by 3 does give me 2. So it's important to note that it's not always, if they're right angle triangles, that it would always follow the RHS rule. Don't fall into that trap, but just make sure that yes, that's my. Also have to check that two other given sides have been increased by the same proportion or by the same scale factor. The word proportion can be interchangeable with scale factor. When we're looking at which tests can be used to prove that each pair of triangles are similar, this is how you would actually see it in an exam situation or in the textbook as questions. And you know you have the choices of 4. So side, 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 side angle, side, equal angular, or two angles the same, or the right hypotenuse side. But looking at that, they haven't given us any other sides. So they've only given us two angles. So therefore, this one was pretty easy. And you know, we always start with really easy and we move on to a little bit more difficult. Because they've only given us two angles, we obviously know that it's the equal angular, or so two pairs of angles are equal. You would actually have to state the reason why these triangles are similar. The next one, we've got a given angle, so visually we know it should be SAS, but we need to prove that by working out the fact of what is the proportion, or what is the scale factor that these sides have been increased by. Well, visually I can see very quickly that 5 times 3 is 15 and 8 times 3 is 24. However, in an exam, you'd actually have to prove that by writing out the right proportion. So 15 over 5 is equal to 24 over 8, which then gives me 3. So, and both triangles have a given angle of 105, so therefore these two triangles are similar given the SAS, so side angle side. The third example, they're right angles, or so right angle triangles. And again, we need to see if the hypotenuse is proportionally increased by the same amount. So again, we put it into the formula, 17.5 over 5 and 18 over 12. We just punch these numbers into our calculator, and they both reduce down to 3 over 2. And 18 over 12 does reduce down to 3 over 2, or 1 and 1.5. And that's again something that you can visually see. However, you would actually have to state it. So therefore, these two triangles are both right angle triangles. The pairs of hypotenuse and the second sides are the same ratio given that. So therefore, they are similar given the right HS. Now, we've got three different sides, so visually we can see it would be side, 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 but we would therefore need to prove this again by putting it into the right relationship. So 11.25 over 15, 9 over 12, 6 over 8. If you by chance flipped it and decided to go from there to there, and you had 15 over 11.25, 12 over 9, and 8 over 6, you would still get the same relationship, but it wouldn't be 3/4, it would be 4/3. So you would still be getting the same answer, and you would be able to still prove that it's side, side, side. So that's pretty much it, using the 4 different tests and working out specifically which test you would use are pretty straightforward visually, as well as just plugging it into the scale factor formula and doing it for each side. And that's pretty much today's lesson done.